Welcome to solverfy.
Solve two problems. In the first problem, the mass is on the top of the incline with an angle alpha and length L, and we have to calculate first acceleration of this mass. So let's presume that the top of the incline is here, and here the box is experiencing the reaction force from the surface of the incline, which is perpendicular to this surface, friction, and also the gravity. So these are three forces which give rise to the motion of the box. Now let's introduce y and x axis. So this is y axis perpendicular to the plane, and the x axis is perpendicular to the incline. So now let's project. Let's find the angle alpha. So this side is perpendicular to this side. This side is perpendicular to this side. So therefore, angle alpha is this one, this guy. So therefore we can find x and y projections of the g vector. So nevertheless, now we have all three forces, and the Newton's equation for this mass looks like following: n vector sum of n friction nmg equals to ma, and acceleration of the box is parallel to the incline because the incline is not moving. Now let's project it onto x-axis. This equation on the x and y-axis with respect to x-axis becomes mg sine alpha minus friction force equals to ma, and on y-axis it is mg cosine alpha equals to n. So we have everything which we know from the first equation to calculate acceleration. It equals to g sine alpha minus f friction force over m, or it equals to 10 meters per second squared times sine 40 degree minus 60 newtons over 5 kilograms. Oh, sorry, 12 kilograms. Yes, now it makes sense. Let's calculate this number. It equals to 1.43 meters per second squared, or roughly 1.4 meters per second squared. So we found acceleration. This question is done. Now let's move on to the next one here. Let's label as question A. In question B, we have to calculate time which is required to go down to the slope. And so here the mass moves from the rest. Therefore, L equals to V0 t plus at squared over 2, or at squared over 2. Therefore, t, or total time of motion, equals to the square root of 2L over A, or square root of 2 times 5 meters divided by 5.4 meters per second squared. Let's calculate it. It equals to 2.67 seconds, which is roughly 2.7 seconds. So that's the solution of question B. Now we have to do the conversions for question C. So here we have to convert 40.0 degrees per second to revolutions per second, revolutions per minute, and radians per second. So let's do this conversion. So as we know, 1 revolution per second equals to 360 degrees per second. So therefore, 40.0 degrees per second equals to 0.0111, yeah, right, revolutions per second. If we convert it to revolutions per minute, then we have to multiply it by 60. So therefore, it equals to 6.6, yeah, 67 revolutions per minute. And lastly, we have to convert it to radians per second. And so it equals to 40.0 times pi over 180 radians per second, which is 0.698 radians per second. So that's the solution of this problem. I hope I helped you. Thank you very much for your attention.